So, my dear children, in this video we are going to discuss about uniform motion and ununiform motion. Okay, அதை பற்றி டிஸ்கஸ் பண்ணுறோம். அப்போ ஃபஸ்ட்டு இந்த ப்ரீவியஸ் வீடியோ வந்து நம்ம என்ன பார்த்தோம் அப்படின்னா வாட் இஸ் மோஷன் அந்த டிஃப்ரெண்ட் டைப்ஸ் ஆஃப் மோஷன் வந்து டிஸ்கஸ் பண்ணியிருந்தாங்க. இப்போ யூனிஃபார்ம் மோஷன் அண்ட் நான் யூனிஃபார்ம் மோஷன் பற்றி நம்ம டிஸ்கஸ் பண்ணுவோம். ஓகேங்களா? அதுக்கப்புறமா மோஷன் அண்ட் இட்ஸ் டைப்ஸ் அந்த பற்றியும் நம்ம டிஸ்கஸ் பண்ணுவோம். ஃபஸ்ட்டு இந்த வீடியோ பார்ப்போம். இந்த வீடியோ பார்த்துட்டு அதுக்கப்புறமா வர எக்ஸ்ப்ளனேஷன்ஸை அப்புறமா பார்ப்போம்.
Look at this man running. He is training to run a marathon. He's covering a distance of 3 meters every second. So the distance he covers each second is constant at 3 meters and he maintains the pace for a certain period of time. This is what we describe as uniform motion. So in case of uniform motion, if we know the constant distance covered for each time period, along with the total time duration of motion, we can calculate the total distance covered. What do I mean by this? If I said this man ran at a uniform speed of 3 meters per second for a minute, can you tell me how much distance he covered? A minute is 60 seconds. Each second the runner covered 3 meters. So 60 times 3 is 180. Don't forget the units. The answer would be 180 meters. Similarly, we can calculate how much distance he will cover in 10 minutes, 20 minutes, or even an hour. That's because he's maintaining a constant speed. Uniform motion. Distance traveled by an object in unit time is called speed. It's distance per unit time. So what will be the units? Can you guess? The SI unit of speed is meters per second. Quite often you will also see speed denoted in centimeters per second, miles per hour or kilometers per hour, but the standard unit remains meters per second. We observe this gentleman here running at a constant speed of 3 meters per second. He is definitely a thorough professional, but in our day-to-day lives, it is very rare to see uniform motion, whether it is walking or running, riding a bicycle or being in a car. We walk briskly for a while and then get tired and our pace slows down. Most of the times, we are not even in control of the speed. There are external factors like traffic lights, busy crowded areas and the like. The bicycle ride is fast at times and slow at other times depending on which area of the school you are in. Same goes for driving a car. Such cases are examples of non-uniform motion. The speed of the object is not constant. So hang on, can we calculate speed for non-uniform motion? As the motion is not uniform, it will have different speeds at different points in time. When it comes to non-uniform motion, we refer to the rate of motion in terms of average speed. Yes, that's right, average speed. So how can we derive average speed? This boy leaves point A to reach point B, which is 60 meters away from A. And he has been walking at varied rates of motion, basically non-uniform motion. He takes 60 seconds to reach point B. So he has covered 60 meters in 60 seconds. What is his speed? Can you tell? You'd have probably guessed. We look at the total distance covered and divide it by the time taken to arrive upon the speed. So this boy has covered 60 meters in 60 seconds. So 60 divided by 60 equals 1 meter per second. That's his average speed over this distance. It is as simple as that. But you have to be careful with the units used. What you have to get into the habit right away and stick to standard units. If you understand it well right now, it will help avoid silly mistakes in the future. If I had said this boy has covered 60 meters in 1 minute, you should not make the mistake of writing 60 divided by 1 equals 60 and say he's traveling at a speed of 60 meters per second. That's as fast as a bike. The best way, normally, would be to convert to standard units. So let's convert 120 meters in a minute into meters per second. Meters is already in standard form. As the standard form of speed is meters per second, we need to convert this minute into seconds. 1 minute equals 60 seconds. This would mean distance covered was 120 meters in 60 seconds. So what was the distance covered in 1 second? Correct, 2 meters per second. So make sure to stick to standard units for now and always mention the units being used. Average speed is a good way to know when you will reach a certain destination in traffic. There will be times when you will be driving fast and other times you will be stuck. Hold on. At every instance, you are moving at some speed. It may be 0 meters per second when you're stuck, or 2 meters per second, or even 4 meters per second. Do you know what the speed at each instant is called? It is called instantaneous speed.
So well children, in this video we were just discussing about uniform motion and non-uniform motion பற்றி சொல்லியிருக்கிறோம். யூனிஃபார்ம் மோஷன் அப்படின்னா ஸ்டார்ட் பண்ண பாயிண்ட்லேருந்து எண்ட் பண்ணுற பாயிண்ட் வரைக்கும் ஒரு பர்டிகுலர் ஸ்பீடில் till the end if it travels. For example, if it is 3 meters per second as it was given in the video, till the end of the journey the same speed is maintained. அப்படின்னா இது யூனிஃபார்ம் மோஷன் சொல்கிறோம். ஓகே, யூனிஃபார்ம் மோஷன் அப்படின்றது வந்து அதுதான் மெயின்டைனிங் அ கான்ஸ்டன்ட் ஸ்பீட் டில் த எண்ட். நான் யூனிஃபார்ம் மோஷன்ன்றது at different places the speed differs. Okay, the velocity, I am just using the word speed there. So 3 meter per second let 2 meters go, 7 meter per second go, mari வந்து if the car is traveling, then I call it as non-uniform motion. So that video I explained it much better. So this is the difference between uniform motion and non-uniform motion. Okay, now we will watch a video about motion and its types. Okay.
Say Ben wants to move this table from point A to point B. What will he do? Yes, he will push it in the direction of point B. You see that as he pushes the table, it starts moving. Anything around us that moves, we say that it's in motion. So this table is in motion. And since Ben is also moving along with the table, he is also in motion. In our day-to-day life, we see various things moving around us. Simple examples that I can give are vehicles moving on the road, people walking across streets, birds flying in the sky, and so on. Do you know that the Earth and the other planets also undergo motion? Yes, they are revolving around the sun. You can give me thousands of such examples of motion. But what if I ask you to tell me the definition of motion? How can we define something as intuitive as motion of a body? Well, for that, we need to look at what exactly happens to a body when it's in motion. Let's say this vehicle moves from point A to point B. You see that as it's moving towards B, its position in space changes with time. Initially it was here, then here, and now after some time it's here. Notice what's changing. The position of the object and the time too, which is changing anyway. The change in position of a body with time is what we call motion in simple words. Whenever there's a change in position of a body, we say it's either undergoing motion or has undergone motion. Let's discuss about the different types of motion now. The simplest type of motion is called the rectilinear motion. Notice that there is a word line in there. So we define this type of motion as a motion in a straight line. Yes, rectilinear motion is nothing but motion in a straight line. So if an object is moving along this straight line path, we say that it's performing rectilinear motion. For example, when a car is moving in a straight line on a straight road, it's performing rectilinear motion. There is one more thing that I want to discuss with you in this video. Assume you're on a railway platform watching the train pass by. You are at rest. For you, both the train as well as the passengers sitting inside are in motion. But will the people sitting inside the train say the same about the other passengers in the train? For a person sitting inside, the people in the train are not moving. They are at rest. So for the observer at rest on the platform, the people inside the train are moving, but for the person sitting inside, they are at rest. What does this tell us? This means that the motion of any object is relative to the observer. For different observers, the motion may be different. We will learn more about this in higher grades. In this video, we understood the definition of motion. We also discussed one of the types of motion called rectilinear motion. In the next video, we will see a few other types of motion.
So that is the first part of the video. So types of motion. So in that video we just saw what is motion and what are its types. We will watch the next video also. So and after that we will just discuss about those videos.
In the previous video, we studied what motion is. We also saw one type of motion called the rectilinear motion. It's nothing but straight line motion. In this type of motion, the path of a moving object is a straight line. But what if the path of a moving object is circular? Yes, you guessed it correctly. If an object is moving in circles, it's undergoing circular motion. More accurately, it's defined as the motion of an object along the circumference of a circle. The circumference of a circle is the length of this boundary which is curved. So if an object is moving along the circumference of a circle, we say it's undergoing circular motion. Can you give me any real-life examples in which objects execute this type of motion? What about the satellites orbiting the Earth? Yes, a satellite orbiting at a certain height is also undergoing circular motion. What other examples of circular motion can you think of? Take a small object and tie it to one end of a rope. Take the other end of the rope in your hand and whirl it around in circles. You see that the object is performing circular motion. Notice that the distance of the stone from your hand is always the same. What about the moving fan? Is it also undergoing circular motion? First, let's only consider the motion of a point on one of its blades. If we switch on the fan, we will see the point moving in circles. So we can say that the blades of the fan are also undergoing circular motion. Now what if I take the fan as a one single object? Can I say that the fan as a whole is moving in circles? No, that would be incorrect. The fan as a whole is not going anywhere. The entire fan is not moving along the circumference of a circle. But which motion is it performing then? The fan is undergoing rotational motion. Before actually defining this type of motion, let's try to understand it first. This rod here is called the axle, and the entire fan is spinning around this axle. Or you can also say that the entire fan is spinning around this fixed line. This type of motion is what we call rotational motion. Now we will define it in simple words. A body is said to be performing rotational motion if it's spinning around some fixed line. And the fixed line is also called axis of rotation. What other examples of rotational motion can you think of? What about a rotating wheel? We use the word rotating because it's performing rotational motion. What is axis of rotation in this case? Yes, it lies on the axle of the wheel. So the wheel is also undergoing rotational motion about this fixed line. Other examples of this type of motion can be the earth spinning around its axis and a spinning top. But wait a moment. Let's go back to our example we discussed earlier. When this object was whirled around in circles, we said that it was performing circular motion. But here, if we take this line as our axis of rotation, then we can also say that the object is performing rotational motion around this fixed line. So what is the motion of this object? Circular or rotational? What exactly is the difference between the rotational and the circular motion? In all the examples of rotational motion that we saw, the axis of rotation is a part of the object. It is going through the object. But in this case, the axis of rotation is not passing through the object. It's totally separate from the object. Hence, we don't call this motion as rotational motion. This is circular motion and not rotational. So this is the difference between circular and rotational motion. If a body moves along the circumference of a circle, we say that it's performing circular motion. And if the body is spinning around the fixed line called the axis of rotation, and if that axis of rotation passes through the body, we say that it's undergoing rotational motion. In the next video, we will see one more type of motion. See you there.
So the video explained about the different types of motion. In both the videos, you find what the difference between rectilinear motion, circular motion, rotatory motion. இதோட explanations கொடுத்திருந்தாங்க. So in the second part of the video, you just saw the difference between circular motion and rotatory motion. Okay, so I hope that you understood the concepts about motion. And in the next video, we will just discuss about acceleration and velocity and the difference between speed and velocity. Thank you for watching. See you in the next video.